So it's the same notes as yesterday, and we are just doing a little bit of review, and you say it's x minus 4. Did you say x minus 4? X minus 4, and what else on the bottom? Plus 1. Good. And then on top, x plus 2, and then x minus 2. All right. Now, why is that helpful at all? It's helpful in a lot of ways. If you want the vertical asymptotes, they come from these two. And if there isn't any hole, which there isn't, because nothing cancels on the top and bottom, that would have created a hole. But since there's a x equals 4, that's a vertical asymptote. X equals -1, that's a vertical asymptote. And since this is same on both, lead coefficient ratio y equals 1, do you get how I could have just seen these and known one of them was a vertical asymptote? Actually, two of them are vertical asymptotes because of the x, and there's zertical asymptotes and horizontal asymptotes. That one's the horizontal asymptote. All right, so next, if this whole thing was set less than 0, if it was, that's one of the hardest kinds of problems. Why? Because then I've got to find the things that make the top 0 also. They aren't asymptotes, but they are things that would make, well, if this was y, do you get I just set y equal to 0, so it's like I'm finding the x-intercepts. So this is an x-intercept, and this is an x-intercept. All right, so then if I were going to be doing this problem where it's set less than 0, I would now have a number line, and the 4 important numbers I would have would be -2, 2, 4, and -1. And that would just be probably considered child abuse or cruel and unusual punishment at least. So therefore unconstitutional because it's got so many parts to it. I couldn't ask you to do that on a test. But I'm going to give you one that's similar. That's got far less things to worry about. And let's see if you could do it.
So you can't be charged with anything?
Nope, this one will keep me safe from the law. Ready? It's x minus 2 over x plus 3, is less than 1. Now it does have an ugly twist. I didn't set it less than 0. Meaning, you can't just figure out what makes the top 0 and figure out what makes the bottom 0 because it's not equal to 0. So what do you have to do first? We did have one like this yesterday. If it's ringing a bell, we did one like this yesterday. First step, subtract 1 from both sides. Now, I'm going to cheat because I'm naturally, well, I'd like to not think lazy. I like to be efficient. So I'm just going to move that 1 over to the other side. Okay, now I need a common denominator. If you can do that, you have an edge on some of the kids in here because they're going to be like, I can't do that part. I hope you can. Put it all together into one big fraction, and then what's the important parts? What makes the top 0 are the x-intercepts. What makes the bottom 0 are the asymptotes. Did you notice we were multiplying by x plus 3 on the top and the bottom? No, why are we multiplying by x plus 3 at the top and the bottom?
Because it's the denominator.
Yep, it'll make the denominator the same. Good. Row 2, person 3. Johnny, tell me what I get. All of this stuff. It starts with x minus 2, and then what's the rest of it? Minus x minus 3. Very good. Now, does anything cancel, Johnny? No. I beg to differ. See those two? Oh. Okay, those will cancel. And then, I know you were thinking on the top and the bottom, and you'd be right. Nothing would cancel that way. But those two cancel. And then, did you guys get -5 over x plus 3? Raise your hand if you had that one right. Awesome. But all you have done is get it ready to figure out what the key things are. What makes the top 0? Nothing. That means it doesn't have an x-intercept. What? Some things don't have x-intercepts? Yeah, like parabolas that say above the line, or a lot of things don't have x-intercepts. How about y-intercepts? Well, we don't care about that. What we care about is the other thing on the bottom. What's the other thing on the bottom? That -3. What is that again? Vertical asymptote. So put a -3 on your number line, because that's the key spot. It only has one key spot. Now, the next thing is I would put an asymptote right through it, because that'll remind you there's an asymptote there. So if there's an asymptote there, that means you're not going to have a filled in dot. You're going to have an empty dot at -3, because, you know, you can always just test it. Stick a -3 in the function, and you'll get something divided by 0, which can't exist. Then we better test like 4. Or no, wait. Something on this side is not 4. I'd test 0, because that's on that side of it, and it's super easy to test. And then I'd test -4. This is the thing that people are the worst at. Figuring out what to test, and then carefully testing them and figuring out, so what do I do now that I stuck it in and I don't even know what I'm supposed to do? What you're trying to figure out is what makes things that are less than 0. So when I put in a 0, did I get an answer that was less than 0? Yes, I did. So it worked. And all that really mattered, and this is something that's hard to get across to people, all that really matters is the thing less than 0 or greater than 0? So all that really matters is, did it come out positive or negative? When I stuck in 0, it came out negative. I don't even care what negative number, it's just that it came out negative. So therefore, it's less than 0, and therefore, I'm going to put a negative here. This is called a sign chart. I'm putting a negative here because I got a negative. And then I go, is that less than 0? Yes. So I shade it in. So there's my answer. Now, could it also be shaded on the other side? Yes, it could. So we better test the -4. And then you see, did it come out positive or negative? It comes out positive, because that's negative and that's negative, and that makes a positive. And so that is not less than 0, because it came out positive. So I don't shade over there. Final answer, -3 to infinity, parentheses. Questions? Yes?
Do you have to use a number line if you have a more efficient way?
I strongly recommend a number line, but in the end, your answer looks like this, and you need to show your work. So just saying, there are other ways, but I know what kind you're going to have on the test. I cannot imagine a scenario that would work well for them other than a number line. But you do you, just warning you, and I'm good with it as long as you show your work. That's the key. So I just am warning you that it's pretty likely you're going to have more than one thing, and it's going to get complicated, and a number line is going to help you a lot. Yes?
So you have to use interval notation. You can't like say like X is greater.
It'll probably say on the test,
Okay.
answer in interval notation.
Right.
But if it doesn't, you don't care.
If it doesn't, then I can't force you to.
And the same
Psychically,
thing for
no.
domain, too.
Now we're changing topics totally. Okay, so on domain, if you give a domain, there is more than one way to give a domain. So there is, you remember the approved forms? Set notation and interval notation and number line notation. So if it doesn't specify, this would have been good enough right there. That's the fastest thing, is just leave that alone, because it's a number line, and number line notation is allowed. But usually it says interval notation. Okay, let's get on to the next important topic. I need to teach you more about how to use a sign chart. So everybody write this one down. And the question here would be, find the horizontals and the verticals, and then graph it. Ask Bob about the horizontals. Maybe it's Bob, maybe it's not. Maybe it's a Sob. And then for the vertical asymptotes, that's always looking at the denominator. And then you'll need an XY chart. The thing I'm going to help you do better here is when you're graphing it, I'm going to help you test right near the asymptotes. Okay, would you agree that this was a bob? Bigger on the bottom, bigger degree on the bottom, and therefore it's y equals whatever's on the outside. There is nothing on the outside, so you could argue that there's a plus 0, so it's y equals 0. Who beat me to that? You had y equals 0. Okay, good. Then the vertical asymptotes. Saloni, what did you get it factored down there? What was it? Correct. And so therefore the vertical asymptotes are? Please say x equals. X equals 3 and x equals negative 4. Okay, good. So everybody graph those. There's negative 4. There's 3. And 0. I'll make that a different color so it stands out off of the x-axis there. Okay, now I need some points. XY chart. Did anybody already think to put in 0 and see what you get? Well, do it. It'll take you like 10 seconds. 0 gives you 0. Good, so it goes through 0, 0. What? It goes right through an asymptote? I think you're over that by now. You get that horizontal asymptotes can be crossed. We still don't cross verticals, ever in this class. But I'm not dumb enough to think that that's impossible in some other universe that I don't understand yet. But if I'm going to figure out where this thing goes, most of you are going to be putting in things like 1 and 2, and that's okay. But here's the thing that's dangerous. I want you to imagine a world where this goes down and then back up again. Is that humanly possible? Could it go like that? Yes, it could. So if you just get one dot, you might think, oh, well, it's for sure going this way. I would have thought that. So if I got only one dot, that would be dangerous. So let's do one dot in there, but we'll see what we get. Did anybody put in 1 yet? What did you get?
I got something really messy, so I don't know if it's really...
Okay, but all it really matters is whether it came out positive or negative. Like, did it go down underneath the x-axis in the negatives? Was it negative?
Yeah.
All right.
1/10 is what I got.
Yep.
So 1 and negative 1/10.
Yeah.
All right. Do you get that that's not a guarantee that it's going to keep going down? So if you also put in 2, that would help. But here's the thing I want to teach you. Do you get that if I put in something really close to the asymptote, I can't put in 3, but I could put in 2.9. Now you might be like, but that's going to get really messy. But all that matters is, does it come out to a negative and therefore your line is going like this? Or does it come out to a positive? When I put in 2.9, it either will end up going this way or it'll end up going that way. So put in 2.9, just wait. So you go just on one side of the asymptote. I would use factored form for this. And I put in 2.9. And what becomes key is whether it's negative or positive. I don't care that that's exactly 6.9. I care that that's just a positive number times a negative number. And this one's also a positive number. So do you get all I really care about is if it's coming up positive or negative. So I got a positive over a negative times a positive. What does that come out to? That comes out negative. That means I know it's going down. Because I tested about as close to the asymptote as I could. It came out to a big negative number too. But I don't really even care. I just care that it came out negative, so therefore it's going down. It is not going up. All right. What would be the other logical place to test in here? Negative 3.9. Everybody do that quick because we want to test right in here. In this zone here. to see if it ends up with a negative number and it's therefore going down, or a positive number and it's therefore going up. So I tested 2.9 and I got a negative number, so I knew it was going down there. I'm testing negative 3.9. Can you guys verify? I think it comes out positive, doesn't it? Okay, so then it goes positive, so therefore it must be going like this. It's going up. You see how that can be handy? Testing on both sides of the asymptote. So I want you to test one more. Test negative 4.1 and see if negative 4.1 tells you in this zone here, on that side of the asymptote, is it going down or is it going up? So at negative 4.1, test it. And here is the function again.
So you don't need them on the test, you don't need them like spot on numbers, you
Nope.
just need general direction.
Yep. So I'm fine with, some kids are going to not like this. They're confused by it and they don't want to do it. I'm fine with you just sticking in 1, 2, 3, and negative 1, negative 2, negative 3. But it's a little faster to just test on both sides of the asymptote if you can understand what I'm doing right now. I'm just testing on just this side of the asymptote, putting in negative 4.1 here. It's a little faster because then all you care is if it comes out negative or positive. And this one is negative on the top, clearly. Over this one would be negative. Times this one would be negative. And therefore, it's a negative or a positive, and therefore overall, it's negative. So I know that this asymptote must be going down right there. Now, could it pass over the asymptote again? I suppose it could. Do you get I could put in a big negative number if I wanted to? Like, what if I tested negative 10 to see if it ended up going through the asymptote or not? I could. I could stick in negative 10 and see whether or not it went through that asymptote. So I'm going to stick in negative 10. And when I stick in negative 10, it's a negative over a negative and another negative, right?
Yeah.
Okay. So I think overall the thing ends up being negative, which means it stayed below the asymptote. There we go. Okay. Now I've taught you how to test on both sides of an asymptote. If the asymptote was at 5, you'd test at 5.1, and you'd test at 4.9, just on both sides of the asymptote. Okay. Now, what else do we have to learn? The cool part is, this is super simple, and it looks a lot like what we just did, but it's so much easier. Why is that so much easier than what we just solved a minute ago, and we had to test all these intervals, and we had to... Why is this so much easier? And so since it's equal to, I can clear the fractions. On those less than ones, you can't clear the fractions. That's one of the reasons it was such a pain. You had to get common denominators and all that crap. Here, what do I multiply by? X minus 1 on both sides, and then it becomes super easy. Boom, boom. X equals 5x minus 5. And if you can't solve that, I have no hope anymore. So that'll be easy, right? So my point is, you got one problem that is super hard with a less than sign in it. Same exact problem with an equal sign in it is super easy. Now, I'm personally going to subtract x from both sides. Some people don't like that because it ends up with 0 on one side. Dear. But some people like to subtract the 5x from both sides, and that would have been okay. I'm going to add 5 from here. And I have 5 equals 4x. And then I'm dividing by 4. 5/4. Raise your hand if you had 5/4. Okay, good. See how that was a nice, easy one? And all I would have had to do differently is make it less than, and you would have had a nightmare problem. You had to subtract 5 from both sides. You had to get a common denominator. You had to figure out what makes the top 0, what makes the bottom 0. Put those on a number line. Test all the intervals around them. Tell whether they're circled in, filled in, or circles are empty. I mean, whole huge pain in the butt when you throw that in.
So which one
Okay.
are we getting on the test?
Oh, you know which kind you're getting on the test. Maybe there'll be an R2 that's just to see some kids think that this problem, they have to do all of that. And like, we need to make sure that you get, this one's the easy kind, and you just multiply both sides by 5 and you solve in a few minutes. So that could be an R2.
A few minutes?
Okay, 2 seconds. Anyway, now here is the last melon. I need to teach you how to find rate problems. And I'm going to give you a rate problem, and I'm going to just give you a chance to solve this and see if you have any clue how to set it up. And then I'll show you the cool, easy way to set this kind of problem up. There's a reason that cartoons sometimes have, like, people in hell who are doing word problems, because it's like, welcome to hell, here's your set of word problems. All right, so anyway, these can be challenging. I'm not saying somebody couldn't figure it out, but here's an example. See if you know how to set this up. And in a moment, I'm going to ask you the same question. You'll be like, oh, I know how to set this up now. So my mom was a really good blueberry picker. She loved picking blueberries. She would go, I'm going to miss the mom blueberry story. Go ahead. Your choice. All right. So shut the door on the window.
Nobody else can hear the
Private
story.
story.
That's right. So my mom was really good at picking blueberries, and she would then use them to make blueberry pies or all kinds of good stuff. And wild picked blueberries by yourself are so much better than the grocery store kind, because the grocery store kind are picked before they're fully ripe. Think about that. Because if you're going to pick them and then ship them across the country, and then they're going to sit in a warehouse for a while, and then they're going to get shipped to a grocery store, you end up with blueberries that have been picked a long time ago and are finally ripe when you get them in the grocery store, and that means that they're not like really fresh. I mean, they're not bad, but the ones that are picked fresh, that are just ripe right now, are the best. So anyway, my mom would make these blueberry pies, and she was really good at picking. Like, she was known for, like, she'd go out picking with somebody else, and this is an obvious comparison at the end, because you get your bucket and you get her bucket, and it was like, holy crap, she just had so many more blueberries than other people. So anyway, I'm going to say that she would pick about 500 blueberries in, I'm going to say, just to make it a little more complicated, 500 blueberries in an hour and 10 minutes. Because she's not going to exactly limit herself to exactly an hour just for a word problem. Okay, so she picks 510 blueberries in an hour and 10 minutes.
510 blueberries or
Sorry. 500 blueberries in an hour and 10 minutes. Okay. Now, I go along, and I am not nearly as motivated. It was okay, but I was like more interested in, like, where's the squirrel over there. Anyway, but I would pick, let's say, about let's go with 100 blueberries in 20 minutes. 100 blueberries in 20 minutes. So then the question is, how long would it take me and my mom together to get 1,000 blueberries? Because we figure it takes about 1,000 blueberries to make a pie. So how long should me and my mom pick together? So that ending was kind of gross. I mean, it makes it hard. So I want you to actually get the answer, and then you can give your answers in minutes or hours, I don't care, but try to figure it out without me. And see if you will know at the end whether you've got the right answer I'll show you how you should set it up.
Is it related to like what we're doing right now?
Yeah, this is a problem that you would have to do on a test. I'm just amazed at the method that I'm going to show you makes these problems easy. When right this minute you're probably thinking this is really hard. So you'll like this method. Okay. So at the end, I totally get you're going to have a decimal that you'd have to probably use a calculator to get the final answer. So if you want to, you can use your iPad's calculator to like divide things out and stuff. Okay, let's see if you're, you know what, I don't feel like just saying, here's what the answer is the right thing to do at this moment. But circle your answer, I'll come back to it, and then I'm going to show you how to set up this kind of problem, okay? So I'm going to give you a different one, and we'll come back to the mom and the blueberries question. We'll come back to it, all right? Because it's easier to teach this with a simpler problem to start with. So here's the simpler problem. Also about my past and my mom and dad. My dad was the type of person who felt like I needed to do some work around the house to kind of earn my keep. I had to, you know, we feed you and we're going to help you go to college someday. The least you can do is, like, I don't know, shovel off the driveway or mow the lawn or pick weeds in the backyard. So I'm going to use picking weeds because that works well for this scenario. So I go to the backyard, and he says, you see all that crabgrass in the backyard? And it stands out from the other kinds of grass. You can tell it's a weed. And he's like, can't just rip it out or it'll just grow back. So you got to get the roots. Okay, so let's say that I am able to pick, write this down, 20 weeds in 15 minutes. Notice how I wrote it in a fraction. This is the rational functions unit. Rational numbers can be written as a fraction. Coincidence? Yeah, it's just a complete coincidence that there's a fraction involved. 20 weeds in 15 minutes. And I am thinking, oh, Lord, this is going to take me forever to pick all these weeds back here. And my dad says that basically I can't, like, have fun this weekend until I pick all the weeds. So I invite my friend Blake over to pick weeds with me, and he's like, no way, I'm not picking weeds. And I say, I'll pay you. Just come and pick weeds with me. And he's like, okay, fine, but then you're going to help me when I have to mow the lawn next. We'll mow the lawn together at my house. So anyway, Blake comes over, and he's picking weeds with me. And I have paid him well because I'm paying him per weed. And he's like, okay, he all of a sudden is a picking machine. So that I know together, Blake and I are going to be able to pick enough weeds to get the job done super fast. Okay, so Blake is able to pick 60 weeds in 30 minutes. Now, the setup I want you to try to remember is that you take my rate plus his rate, and you get the total rate. And the total rate, so far I don't have any variables here. So if I don't have any variables here, then I need to put an X here. But if I just put an X, my answer will be weeds per minute total. So watch how you finish. The question might end like this. Working together, I need to get 1,000 weeds picked. Okay, it's 1,000 weeds back there. How long is it gonna take us to pick the 1,000 weeds? Do you get from the setup that the weeds would logically be on top? Do you get from the fact that we're in the fractions unit that this is probably going to be a fraction? So then 1,000 weeds goes here. And do I know how much time it will take me? Yes? Wait. We don't know the time yet. Now, you may have calculated it, but my point is we don't know the time, so we put an X here. And we'll be able to calculate the time. All right. So X or N or whatever variable, that's the thing we don't know, and it's in minutes. Do you see how I made it weeds over minutes, weeds over minutes, and weeds over minutes? Because if I had changed that last thing to hours, you get how if it's in minutes in the first part of the problem, it better be in minutes at the last part of the problem. You can't change the units. Now, I could change the whole thing to hours if I wanted to change that 15 minutes into a quarter of an hour. And I could change this into a half of an hour. And then my answer could have been in hours. All right, but do you see how I set that up? Now the cool part is I can just drop the units because I know I set it up from the units. So now it's 20 over 15, and can't that be reduced? Sure it can. And then it's 60 over 30, and can't that be reduced? Super easy. What's 60 divided by 30? 2 equals 1,000 over X. And now, doesn't it look like one of those easy ones? There's no less than. So therefore, I don't have to like test intervals and all that crap. So, yay, I can just clear the fraction. What am I multiplying everything by? Well, wait. First, let's simplify the 20/15ths even further. What is 20/15ths reduced to? 4/3. And now I can multiply everything by 3x. 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 3's cancel. So now it's 4x plus 6x equals x's cancel. 3,000. 10x equals 3,000. Divide by 10, divide by 10. Cancels. 300. 300 hours? 300 minutes. Divided by, if you wanted to figure out hours, right? We could divide that by something. Divided by 60. And what would it be? 5 hours. With my friend, it's going to take 5 hours. Yeah. And then I could ask the follow-up question, how much do I owe my friend? That would be a good question. Say, let's say that I was paying him 10 cents a weed. Well, I'd have to figure out how many weeds he pulled, right? So I could figure that out. Let's not do that as a follow-up. It'd take too long, but you could. All right, so let's just see if you are skilled enough to set these up now. Let's go back to the blueberry question with my mom. We'll see. We'll work it out right now. I'll show you how to set it up, and then you'll see what... Okay, we'll find out. So, how should I set it up? Well, remember my mom's rate? What was her rate? 500 in, ooh, fancy, 70 minutes. Okay. Plus my rate, which was what? 120 minutes. Which wasn't really that bad, but it was... Anyway, and then equals what did I say I wanted? 1,000 in how many minutes? X. That's the one I don't know. Okay. So now that I've kept my units all straight, I can just drop them. So now I can simplify these numbers. Cancel, 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 cancel. 50/7 plus 10 over 2 is 5 equals 1,000 over x. Clear the fractions.
Are we not gonna have a calculator on this?
Oh, times 7x, hold on. You will not, I don't think you will have a calculator on this test, but that means we have to keep the numbers reasonable. Okay, so times 7x, and then the 7's cancel, and the x's cancel, and I get 50x plus 35x equals 1,000, so that's 85x equals 1,000. Oh, wait, what? What'd I do wrong?
You didn't multiply by 7. You're 1,000.
Oh, 7,000. Thank you, not 1,000, 7,000. Okay, and then divided by 85. What is 7,000 divided by 85? 82.4, actually.
Oh, let's go.
Apparently you guys got it. Nice job, without any help. That's impressive.
I did it really weird.
No, I did it so differently.
I did it.
Well, not so different.
It's fine. If you got that answer.
In terms of 20 minutes, so I
Yeah, no,
had
so
that
yeah,
to multiply it by 20 and
I think it's cool that you found a way to do that without that method.
I did it the exact same way that
No, yeah.
All right.
Yeah,
I would like to try one more without my help, and I do remember that I gave you a whole bunch of, I gave you a quiz to take last night, and we haven't graded that, and I'm going to assign the rest of today's homework, and we haven't, of course we haven't graded. I haven't even assigned it yet, but we have a few things out there to grade, so warning, tomorrow we're going to be grading something. I'm not going to tell you what, but keep on doing the homework that I've been assigning you. All right, maybe 2 of the 3. Probably not all 3, take too long. Do you get how it's a rate plus a rate equals a rate for both? Just see if you can set this up. Don't even solve it, just try to set it up. Chestnut, that's the last name for this guy. I think it's Johnny Chestnut. Joey, thank you. Apparently you know him. He is the true champ on hot dogs, and he eats a ludicrous number of hot dogs. In this problem, it's 70 in 10 minutes, but I think in the real world, well, somebody knew his name. Do you know how many he meets? Okay. He is the actual real champion. Like, they've been doing it for many years, and he's just got this freakish ability to eat tremendous numbers of hot dogs.
Have you seen how they eat it really quickly?
Yeah, they just like
They
kinda
take-
slide it down
They
their
dip
gullet.
the buns in water. They dip the buns in water.
They dip it in
They
water.
Swallow it, and then they essentially like swallow
Shove it down their throat.
Yeah.
Why do they dip the buns in water?
It
Because
slips down and
otherwise, if it's kind of dry, it just like sticks in your throat and stuff. So they,
It
yeah.
probably takes up way more space.
Yeah, the water.
But they actually train for this. They don't just like one day, okay, it's my day each year that I go and eat a gajillion hot dogs. They actually train for it. I know, it's pretty disgusting. Okay, so he's eating 70. I'm going to put HD in 10 min. And I know you're getting tempted to not write the units, and that'll burn you because a lot of times they'll mix in minutes and then hours. And then you'll get, you'll be not right because you haven't been careful with the units. Esper is 100 in 8 minutes.
No, that's
Oh, that's both of them. Thank you. So then I need a rate for Esper. Well, I'll put an X there in a minute. But wait. Not just an X. 100 HD in 8 min. Okay. How long will it take Esper to eat 30? So this is how long, so that's the X is on the bottom. See, this is the important part of having the units there. How long is unknown, but the 30 hot dogs, that's known. And now I can drop my units and simplify things, and 70 over 10 is 7. And we're not going to have units anymore, so it's just 7. Plus 30 over X equals 100 divided by 8.
It's like 12.5.
Thank you. And then do you get from there, it's easy to solve. I love that I can get to this and go, yeah, you know how to do that. Just multiply everything by x, easy. Okay, so it's the setup on these that's hard. So then what should you do for homework tonight? You should go back to the same assignment I gave you before, and I gave you a pittance of problems, only a couple off of this. So I'm going to add to it just a little bit. Not going to give you any more of the easy ones, but one more of these. That's, I told you, hardest problem that we'll test you on. And it's mostly because of the unit, or not the units, mostly because of the testing the intervals. Okay, and then these are both confusing to me. I don't like the way they set them up. I'm not doing those. I'd like you to do this llama pen question. That's very similar to the type of question that we need you to know. And one more of these, we're going to cherry pick number 16. I want you to do number 16. And then this last question, it'd be so tempting to just try to make your life easier and say, oh, you can skip it. But I'm telling you, you have to know how to do this. And I'm going to take one more minute to help you set it up. On a word problem that involves like area or perimeter or whatever the thing is that it's about, you've got to start with the equation. Do you remember doing volume is length times width times height? Do you remember how I emphasized you have the whole formula, both the left side and the right side, because we might someday tell you the volume? Well, someday has arrived. So we're not telling you the volume, but we need the whole formula, not just length, width, height. You need volume is length, width, height. What is this one about? This one's about fencing in a garden. Do you get that fundamentally that is like a perimeter question? If you're talking about the fence, that's like adding up around the outside, and that's perimeter. So you are forced to remember what's perimeter again. 2 lengths plus 2 widths. Very good. But in this case, we don't have 2 lengths. I always say to pick the longer side, which appears to be the x, and say that that's length. But we don't have 2 lengths because the side of the house is acting like one of the sides of the garden. You don't need a fence along your house. What are you going to keep the house away from the garden? That's dumb. So you don't need fence there. So we just have 1x. And what if they tell you the amount of fence that you have? What if they told us that we wanted only a certain amount of fence, we could put it here. But that's not what they do. Instead, they tell you the area. So I'm going to leave P as just P. But if they had told me the perimeter, I would have put it there. Then 2 widths is like 2 y's. Are you with me so far? But now I have to replace P with something to do with the area of the garden. I mean, they say the area of the garden needs to be 100 square feet. I hope you know the area formula. That's another big formula, but we know a lot of pieces of it. In the context of this garden, don't we know the area? Didn't they say it in the problem? Didn't I just circle it a few seconds ago? What was the area of the garden? 100. And don't we know what we're calling L? What is length again? X. And what's the width again? And do you get now, I have this equation and this equation, and couldn't I use substitution to get it down to just like one equation? Couldn't I get my x, to get it down to just 2 variables left, perimeter and either x's or y's? Yeah, you could. You could use substitution. Another way to say this is, from here, you have to figure out, I'm not telling you the final answer, what other thing we know that helps us like change this problem. And this is a good start. And this is a good start. And then you got to put it all together and you'll be able to do that same thing we did last time. You remember that deal where it was kind of like this? When we graphed the box that had the corners cut out of it? Remember that? And when you sketched the polynomial, you ended up going, oh, it's between here and here. That's the domain. Only logical to be between 0 and, let's say, 5 or whatever. And that somewhere in there is the maximum. Except on this one, pretty sure you're allowed to use a calculator. Double checking if it says anything. I remember this one. You're going to need a calculator to do it. So, hey, I know some of you are going to be like, that sounds hard. I'm not doing it. Okay, fine. But it was my job to tell you what you needed to know, and now it's whether or not you're going to do your job, which would be at least try, and then maybe check the answer key and try to figure out what's going on so that you're better ready for the test. We will talk about that problem more, not that exact one, but ones like it, because we're not ready for the test yet. But we're getting there. Gut says it's early next week. It's not Friday for sure, of course, but I think by Tuesday of next week is my best guess. But I'll tell you when we're closer. Yes?
Did you say we're doing 4 and 8 on the first two pages?
I can't go backwards. It'll mess up my video. Can somebody verify for her which ones I said to do? I told you which problems to do and I circled them. Can you look back and see which...
16, 25, and
You said we're skipping the words.
oh,
I can just go back and check the video later.
The kids that are right near you are going to be able to tell you. So, all right. Anybody watching the video, you can obviously just rewind. So, all right. And that's all I have for you for the video for today.